Direct and inverse variation. Two types of mathematical models occur so often in various sciences that they are often given special names. The first is called direct variation, and the second is called inverse variation. Direct variation. If the quantities x and y are related by the equation y is equal to kx for some constant k, we say that y varies directly as x, or y is directly proportional to x, or that y is proportional to x. The constant k is called the constant of proportionality. What this is saying essentially is this: as x gets larger, y gets larger. As x gets smaller, y gets smaller. There's a direct relationship to how they change. Okay. Inverse variation. If the quantities x and y are related by the equation y is equal to k over x for some constant k not equal to 0, we say that y is inversely proportional to x, or y varies inversely as x. What this equation here is saying that as x gets larger, y gets smaller. As x gets larger, y gets smaller. Or as x gets smaller, y gets larger. An example of this in real life would be something like the effect of gravity. Think of your relationship to your distance to the earth from where you're sitting. It's very small, but the effect of gravity is quite large. Now, if you were standing on the moon, the effect of the distance would be quite large, and the effects of the Earth's gravity would be quite small. There's an inverse relationship here. There are other common forms of variation. This one here, a physical quantity sometimes depends on more than one quantity. If the quantity is x, y, and z related by the equation, z is equal to kxy, where k is a constant, we say that z varies jointly as xy, or z is jointly proportional to x and y. This is a variation of the direct equation. Another way of looking at this is that as the product of x and y gets larger, z gets larger. As the product of x and y gets smaller, z gets smaller. Okay. Mm-hmm. In this next one here, if this in this relationship here, we say that z varies jointly as x and y, or as inversely. We see that z varies inversely as a product of x and y, or z is inversely proportional to x and y. Okay. What it's saying is there is that as the product of x, in this case here, as this product gets larger, z gets smaller. As this product of x and y gets smaller, z gets larger. There's an inverse relationship here. Sometimes they can be combined. You can say in this case here, z is proportional to x and inversely proportional to y. So let's look at some examples here. The tension in the spring varies directly as the distance x is stretched. So we're given that T varies directly as x. So that tells us the relationship there, how they relate to each other. This is a K. Okay. Let's see if I can fix that a little bit. There. T varies directly as x. And initially we are told that T is equal to 8 when x is equal to 2. And K is unknown. Then they give us a new set of conditions, and they say they want us to find out what T is when x is 4 and K is still unknown. So what we can do is plug in the first situation. We know the first two variables. We can solve for K, so we get a model for the equation, and then we can find T. So I can plug in here for I'll have 8 is equal to K and x is 2. So that tells me that K will be equal to 8 divided by 2, which is 4. So I know what K is now. So K is 4. So K is 4. Okay, so that gives me a model to work with. T is equal to 4x. And they tell us that they want us to find T when x is 4. So in this case here, T is 16. The tension is 16 pounds. And that's our answer. All right, let's look at another one. So the length of a rectangle, the length L of a rectangle is inversely proportional with W. So that tells me that L is inversely proportional to W. That tells me how to set it up when I see that right there. Initially, we are told that L is 6 when W is 2 and K is unknown. They want us to find L when W is 3 and K is still unknown. So what we have to do is find K, get a model, then use it to find L in the new set of conditions. So in this case here, I can solve for K. K will be equal to W times L. K is equal to 2 times 6, which is 12. Okay. So now I have a model I can work with. L is equal to 12 over W. There's our model. In this case, we know that W is 3, so I can plug in there. Okay, so L 12 divided by 3 is 4. The length is 4 feet. That's a misprint there. Okay. The key to understanding these problems is you want to recognize those literal phrases, varies, directly, inversely, so you know what equations to use when you set them up.